Okay, I'd like you to watch this video on relative motion before Monday's class so that on Monday we can solve problems. Relative motion is just a way of saying that sometimes different people will say different things about the motion of the same object. All motion is relative. It just depends what frame of reference or where you are. So like I've said, the motion can differ in different frames of reference. So what's a frame of reference? Well, if I'm standing on the ground, that's going to be my frame of reference. And anything I measure is going to be compared to the reference point of the ground. If I happen to be standing in the back of a moving truck, then the moving truck would now be my frame of reference, and everything is going to be measured to it. So think about a plane flying in the wind. I've drawn a picture down there. I've put in a picture down there, and you can see. If the plane heads out in a certain direction, the wind is going to blow it. And it might end up going in a different direction than it headed out in. So the resultant velocity of the plane is going to be the addition of the plane's velocity without the wind plus the amount of velocity that the wind is adding. So it's going to make your life a lot easier if you use proper notation when you solve relative motion problems. And the first subscript is going to represent the moving object. So here, the P would stand for, say, plane. And the second subscript will stand for the frame of reference, like this one. So the above equation here would mean the velocity of the plane with respect to the earth, or I'm calling it ground, equals the velocity of the plane with respect to the air, and that's the velocity without the wind pushing on it, plus the velocity of the air with respect to ground. And that's going to give me my resulting velocity of the plane with respect to the ground. So notice the pattern. In the addition side, on the right-hand side of the equation, those middle vectors, those middle letters, sorry about that, those middle letters are the same. In the resultant subscripts, they become the outside subscripts of the equation in the addition. So now I'd like you to try and take the following four vectors, try to rearrange them in proper relative motion equation notation and see if you can come up with some sort of equation that makes sense. So I'm going to show you on the next slide the solution. You may want to pause here so that you can try it yourself. So did you get something like this? Notice that the resultant, the AX, are the outside subscripts of the equation on the right. And those middle ones are the ones that match. So now some terminology. You're going to notice that in many of the problems, they use something and they ask you to find something called heading. This is the angle that the moving object heads out in. It is not the resultant's angle. So in a plane or wind problem, it's the angle of the vector VPA. It's the angle that the plane headed out in. It is not the angle of the result. If we have a question with a swimmer who's swimming in water, but the water current is pushing them another way, then the heading will be the angle of the vector velocity of swimmer with respect to water. It will not be the resultant velocity. So now, the last thing I want to show you is just a problem taken from an old Nelson textbook. See if you can do it. Now notice that normally we would not draw that little vector diagram for you. We would expect you to draw this. And the other thing that we would expect you to do, even before you draw the vector diagram, is for you to write out your vector equation. So it would be VCS, or velocity of canoe with respect to shore, equals velocity of the canoe with respect to the water, plus the velocity of the water with respect to shore. These two vectors will add up to give me what direction the canoeist really ended up traveling in. So I'd like you to try this yourself, and if you don't get it, then you can have a look at the solution on the next slides. But on Monday, I would like you to come to class having viewed this video and having gone through this problem. There are also some other good examples in your textbook on pages 45, 46, and 47. So please come on Monday and ready to solve relative motion problems. See you then.